Here's an example of a limit comparison test problem. So remember, the limit comparison says that if the given series AK and BK, if the limit of AK over BK is greater than 0 or finite, in other words, between 0 and infinity, then both AK and BK act the same way. They both converge or both diverge. Okay. So what I'm going to do is I need to compare the given series should be a K to a reference series. Okay, so what I do is I'm going to take this out and I'm going to compare it to a P series. So I'm going to look at this series, 2K3 plus 2K minus 7, 5K to the 5th minus 2K to the 4th plus 13. This is going to be pretty much similar to this series. And which is going to be 2/5 1 over K. I'm sorry, that's to the cubed, and that's to the 5th. So I just take the two highest order terms. That's going to be really close to 2 over 5, 1 over K squared. And I want to note that this series converges since P is equal to 2 greater than 1, and that's because it's a P series. So this series converges. So I'm going to compare, this is going to be my BK, and this is going to be my AK. So I'm going to take limit AK over BK. That's going to be equal to the limit 2K cubed plus 2K minus 7 all over 5K to the 5th minus 2K to the 4th minus 13, and that's going to be over 1 over K squared. So I'm going to need to continue this here. Well, that's going to be equal to the limit 2K cubed plus 2K minus 7, 5K to the 5th minus 2K to the 4th minus 13 times K squared over 1. That's equal to the limit K goes to infinity, 2K to the 5th, 2K cubed minus 7K squared. Just rewriting the bottom. The highest powers dominate. This is going to be equal to the limit K goes to infinity, 2K to the 5th over 5K to the 5th. Well, that's just 2/5. And that's my limit. So, since 0 is less than L equals limit AK over BK, K goes to infinity, equal 2K cubed plus 2K minus 7 over 5K to the 5th minus 2K to the 4th plus 3 all over 1 of the K squared. You don't have to write all this. Equals 2/5 less than infinity. Both series act the same way. Sorry, that's k squared. Since 1 over k squared converges, so does the given series. And that's by the limit convergence test. So quick review. Given this series, I figured out that it was going to be very comparable to 1 over k squared, which converges. So I take this limit, ak over bk is this. After some algebra, I simplify it and I get 2/5 as my limit. And so I'm saying since my limit, I don't really need to write this, you can just write that. But it's ak over bk equal ak over bk, which is this limit, is equal to 2/5. It's both, finite. It's both positive and finite. Both series act the same way. Since this converges, because p is equal to 2 greater than 1 is a p series, so does the given series by the limit comparison test. Well, good.